Electromagnetic interference, EMI, is the problem caused by the electromagnetic waves emitted from electric and electronic devices. Immunity of the devices to electromagnetic interference from the outside is called electromagnetic susceptibility, EMS. These two are collectively called electromagnetic compatibility, EMC. Oscillating, RCC circuit. The received AC voltage in a commercial frequency is converted into the high-frequency rectangular waveform of several dozen kHz by the on-off switching of the MOSFET, shown in the center of the diagram. The harmonics contained in the rectangular waveform are the cause of EMI. The electromagnetic noise generated by the power supply can be categorized into two types, depending on the propagation paths. One is the conductive emission propagated from the power supply to the power input. The other is the radiation emission propagated to space from the equipment as electromagnetic waves. First, we will explain the conductive emissions test used to measure conductive emission. In this test, the conductive interference wave that returns from the equipment to the input side through power line and communication line is measured to make sure that the interference wave does not exceed the limit. To stabilize the power supply impedance, a measurement is made with the AC power applied via the line impedance stabilization network. Listen. This graph is an example of the conductive emissions test results. The x-axis represents the frequency, from 150 kHz to 30 MHz. The y-axis shows the level of the noise terminal voltage. The voltage generated in both phases must be measured. And all the measurements must satisfy the limit, represented by the black dotted line. Next, we will explain the radiated emissions test. In this test, the electromagnetic radiation level from the equipment is measured to make sure that it does not exceed the limit. The electric field intensity received by the antenna, located at 10 meters from the equipment in operating condition, is measured. This graph is an example of the radiated emissions test results. Similar to the results of the conductive emissions test, the x-axis represents the frequency, and the y-axis shows the level of electromagnetic radiation. The measurements obtained with the antenna, changing in both the horizontal and vertical directions, must be within the limit indicated by the black dotted line. This concludes the explanation of electromagnetic noise and the EMC regulations.